webinar. Hope everybody can see the screen here. If there's any issues with the voice quality, please relate that to Hannah. We'll strive to improve that for future webinars. We did work a little bit on improving the voice quality, so hopefully this will improve it. Today I'll be talking about considerations and what we see as industry trends for commercial PV systems. And these insights come from speaking with our network of dealers, installers, and suppliers, and hopefully they'll help you design, install, and sell more commercial systems. There we go. So some of the topics that we'll be discussing today. I'm going to briefly talk about the ITC extension and also the value of including discussion of macros depreciation for commercial customers. I will be going through an example of a system and the value of including the macros depreciation that you can include there. We're seeing an increasing trend of 60 cell modules being used on commercial, so we're going to talk about those trends. Also sizing the arrays with regards to inverter capacity, and also discussing the optimal tilt on commercial projects on flat roofs especially. Going to talk about our trends that we see in developments for ballasted systems, and also offer a view of the ballasted system choices we have available from AEE Solar. I'll go through a brief example of maximizing the output on a commercial roof with various tilts. Finally, we'll be discussing some of the trends we're seeing with NEC 2014 rapid shutdown requirements for commercial projects. You're going to be seeing that in more and more states going forward. And also we will discuss commercial ground racking solutions from AEE Solar and briefly mention some considerations for where to put those inverters in relation to the ground mount array. So before we talk about any of the industry trends, let's talk briefly about the extension of the 30% tax credit for residential and commercial systems. So it is a 30% tax credit available for residential and commercial properties. And the solar investment tax credit per SEIA.org has claimed that annual solar installation has grown by over 1,600% since the ITC has been implemented in 2006. In late 2015, Congress approved a multi-year extension of the residential and commercial ITC tax credit and also changed the rules a little bit, so this is very important to consider. They put the terms, it used to be placed in service standard to qualify for that year tax credit, and now it's a commenced construction standard. So please look at that. That is very important qualification. Used to be you have to have all your system all up and running and commissioned prior to claiming it for that year. Now we have a commenced construction clause. So the existence of the tax credit through 2023 now and beyond provides market certainty for companies and helps them develop long-term investments and strategies which will help drive innovation, competition, and hopefully we'll see lower costs to customers and more solar being employed. So the 30% tax credit, it's 30% through 2019. It then drops in a staged amount to 26% in 2020. 22% in 2021, and then for commercial properties, there's no expiration of the commercial ITC. It'll be 10% from then on in its current form. Also to consider is alerting your customers, your potential commercial system customers, of the ability for them to recover some of the costs of the system as well as a depreciating asset. And for solar installations, that's allowed under a 5-year accelerated depreciation schedule. And this could be, 10% of the system cost in tax credits available to your customer. Please note we're not tax attorneys. We're just relating these options here. So tax accountant or tax attorney needs to review these options and make sure that they are applicable prior to the customer actually filing for those. Here's the example that I came up with here. Again, please have a tax attorney verify all these numbers. So this example assumed a $2.50 watt per installed system cost billed to your customer. Regional variations for system costs do apply. This is just an example used to calculate the tax credit, so please don't use this for pricing purposes or comparisons. IRS Form 4562 is used in calculating the allowed macros depreciation for a 6-year recovery period. So 85% of the net PV system costs are eligible to be depreciated, and the depreciation schedule varies from year to year. So it is not an easy thing to calculate, but a tax attorney would be knowledgeable about this. So the first year you're allowed to deduct 20%, followed by 32% in year 2, followed by 19%, and so on. This determines the deduction allowed. The actual value of the tax credit would be dependent upon what the company is paying for a corporate tax rate. So in this example here, we're assuming a 40 kW PV array with a total system cost of $100,000. And this particular example, we're assuming that the company is paying a 30% corporate tax rate. So in year 1, they can claim the 30% ITC credit. That would be $30,000. Tax savings after you determine your depreciation schedule and the amount that you can deduct, then calculating that tax rate, this is the deductions that this company would be allowed. So in year 1, $5,000. Year 2, $8,000, followed by year 3, $5,000, and so on. So as a result, the net PV system installed cost over a 6-year period, after considering both ITC and macros depreciation, we started with a $100,000 system cost, 30% of that was for the ITC, and then there's a $21,000 additional tax deduction over the 6-year period, resulting in a $48,500 net system installed cost to the customer. So the system dropped from $2.50 that they're being charged, and after tax credits are applied, it's $1.21. So almost 50% of the project costs have been offset by tax credits. Please note this is also independent of any value of the energy that the customer is seeing being produced by the system. So if they're offsetting demand charges, if they're offsetting kilowatt-hour charges, or if they're being hit hard with time of use, you know, that's normally what we're considering as benefit to the customer, but here the tax credits are a big part of that. There still exists also regional grants and other methods to help offset PV installation expenses, so please consult your local JHA, your utility, or also look up the national database of state incentives for renewable energy, and that was at www.dsireusa.org. So some considerations we're seeing now with 60 cell modules versus 72 cell modules. It used to be that the 60 cells were used primarily for residential. The 72 cells were primarily used for commercial. So the 72 cell modules, we're seeing that the industry seems to be standardizing more on the 60 cell format. So they're making most 60 cell modules now can be obtained at or at a lower cost than the equivalent 72 cell modules. So you are saving a little bit in the racking and installation, but as we see going forward, you may not be getting as much power on the roof. 72 cell module formats, they also are not as available as 60 cell equivalents, so you may have to order in pallet quantities or in container quantities to obtain your 72 cell modules if your supplier is not stocking them. So power densities, we talked about maybe higher using 60 cell modules. Here is a comparison of some modules that are available through AEE Solar. So our standard polycrystalline module would be the REC group. We also have the Hyundai 260. So comparing the Hyundai 260 60 cell module to the REC 315 72 cell module, when you calculate the actual watts per square foot, they're fairly equivalent there. REC has made some advances using their twin tube technology. So in using 120 half-cut cells, it's still considered a 60 cell module for voltage and current. But by lowering the internal resistance, they're getting 280 watts out of that polycrystalline module, and the watts per square foot on that module is actually 15.5. Comparing the Soneva 285s versus the Soneva 325 72 cell modules, we can see that the Soneva 285s do also achieve a higher power density for the same size when you're considering square footage of a roof space. Finally, there are high efficiency modules in the 60 cell format. The LG 315 and soon to be 320 module that we have available, we can achieve 17.5 watts per square foot using those modules, and we're seeing some tight roof spaces, some commercial applications trying to get the largest PV array possible, and they are using these larger higher efficiency modules. Also make note that with the 72 cell modules, since they are supporting a larger area there, thicker frames have to often be used, so the modules can be heavier per watt. Usually you need 2 people to handle a 72 cell module safely and effectively. And not that this matters too much for commercial, but we do have more aesthetic options available for 60 cell modules. So down below there we have listed some common watt classes that we're seeing in 60 and 72 cell modules. The high efficiency note is usually not available in the 72 cell modules frame. So some of the other trends we're seeing is that installers are typically specifying higher arrays compared to the inverter output. So typical in the industry was trying to keep under 120% DC to AC ratio. So for example, 100 kW array, typically they try to keep the AC output, the AC value of the inverters at about 80 kW. We're seeing that being pushed up higher, so 130%, even up to 135% is becoming more common. And as a result, our inverters reach peak output earlier in the day, and minimal clipping is allowed during high irradiance periods. Overall, we're getting more kilowatt hours generated at each site, and we have a lower balance of system and inverter cost as a result. Remember that modules are listed at STC output for comparison purposes to other modules, but the NOCT value or the PTC values are more representative of what the modules are going to be outputting once they are installed. So maximum output of an array is only achieved during very limited hours around solar noon, and also during summer months. So during the winter and also during mornings and afternoons, the inverters are still, they're not reaching that peak output, so they're not clipping any lost power. There are calculators, such as PV-Syst, that can be used to calculate the amount of power actually lost due to clipping. The Solar Edge design tool also will give you an indication of when you start having clipping and what the result is. And then you can calculate the inverter capacity that you need for the array, and you can choose it intelligently based upon the additional power that you can produce versus the cost of adding additional inverter capacity. It used to be also common to tilt up the modules pretty steeply to try to get the most out of each module. With dropping module prices, again, that's not so much of a concern. So higher tilts facing south, generally we see larger inter-row shading and we lose capacity on the roof. The majority of net metered solar production that we have is during the summer months, and lower tilt angles allow us to deploy larger PV arrays, and as a result we can get higher energy production out of a given roof area or ground mount area. We're also seeing that an east-west orientation, which uses a seesaw pattern without modules tilted south, they're instead tilted, the first row is tilted east, followed by a row tilted west, so up and down in a seesaw pattern. That completely eliminates inter-row shading, and we can maximize the energy density on a given roof space. Some of the trends that we're seeing in commercial roof ballasted systems. So flat roof arrays using ballasted systems, they're very quick to design. Typically we can get a racking solution designed within a day and a quote quickly soon after. They're fairly quick to install since you're not penetrating the roof and you're not having to flash and protect the roof from penetrations. Typically there's fewer materials that are required than rail-based systems. So fewer SKU counts, fewer materials up on the roof. It also minimizes or eliminates the need for roof penetrations, as we mentioned. It avoids sealing problems with the roof. If there is ever an issue with the roof, it's easy to service the roof by removing a small portion of the array, getting in there, fixing that particular roof surface, and then quickly redeploying the array. Overall, we're seeing less roof warranty issues as a result. Some of the limitations that we have for ballasted systems, however, is that seismic-related building codes, for example in California, they may require some penetrations even though you're using a ballasted system. Typically we're seeing that systems are not suitable for roofs with slopes greater than 5 degrees or roofs over 50 feet high. So since they're anchored by friction on the roof surface. When we start to go higher than 5 degrees, that becomes a problem. We have to specify either penetrations or higher ballasting, and that all has to be cleared with the racking manufacturer for each specific installation. It's also not suitable for roofs over 50 feet high because we start to exponentially have higher and higher wind loads the higher and taller the buildings go. Wind exposure really does drive the ballast and module tilt limitations for these systems. So also please be sure to supply the correct wind loads for your particular area. There are wind maps available for most of the continental United States, but there are some places that have special wind loads, especially along the coastal regions or in certain parts of the country. So check with your jurisdiction for the correct wind loading for that particular install, and make sure that it is used in the calculation when a racking solution is proposed. So some comparisons on penetrated systems versus ballasted systems. The roof penetrations into the structure will anchor the array in a penetrating system, whereas the weight of the array plus the ballasting anchors PV systems in a ballasted system. We have to seal the roof penetrations for the 20-plus year life of the array in a penetrating system. We have few to zero penetrations required in a ballasted system to anchor the array. If the customer does have a smaller system, on a penetrating system, typically we can achieve higher tilt angles. So if the guy only needs 20 kW of PV and that'll fit on the roof and we can tilt it to 35 degrees, we could get slightly higher output out of those modules if we do a higher tilt, and that is available using penetrating racking, even on a flat roof. Ballasted racking, we typically want to keep the array to 10 degrees or less, and this will limit the amount of wind stress on the system and greatly lower the amount of ballasting required. The penetrating racking, we can install that on pitched or flat roofs. We mentioned that the roof pitch is limited on ballasted racking. And also the penetrating racking, sometimes we can get a lower weight than ballasted racking. We supply less dead roof load. So if the roof is limited in the structure that it can support, maybe we have to do a penetrating racking. On a ballasted system, we do have higher roof loading due to ballasted weight. In a penetrating racking system, the roof maintenance requires that you remove the array racking, service the roof. Reinstall penetrations is usually a very complicated process. In a ballasted racking, if we have a problem with a certain area of the roof, we can quickly and easily remove that portion of the array, move it onto the side, store it temporarily, service the roof, and then redeploy the array. Sometimes hybrid systems, so we can take a ballasted system and for the most part have that ballasted system out there, but we can put some penetrations in key points, so the majority of the array is less expensive and quickly deployed and installed because of the ballasted system, and there's key points that are anchored. Fewer penetrations are required to install in flash. Most of the array is still removable for servicing the roof. And the penetrations, a couple penetrations in there, will lower the overall ballasting requirements and could allow a ballasted system to be employed where roof loading is a concern. So it's the best of both worlds there. Obviously, more penetrations require less ballasting and less penetrations more, and vice versa. So a combination of penetrations and ballasting may be the best way to meet wind and seismic load requirements in each jurisdiction. So some of the systems that we have offered through AEE, EraCompact is a fairly new supplier to us. The modules are laid out in landscape format. I have some pictures of these arrays at the end of the presentation. If we have time, we'll look at those more closely. It's offered in a south-facing 5, 10, and 15-degree tilt option. And also a unique to first time for AE is an east-west 10-degree tilt. And again, we mentioned that that maximizes the module density you can put up on the roof and also greatly lowers the ballasting requirements. I have an example I'll show you in a couple minutes. 25-year warranty, it's wind tunnel test 150 miles an hour. There is a special alpine bracketing if snow loading is excessive. We have an alpine system as well. We don't see that typically in the United States, but some areas may need that, more typical in Europe. It is UL 2703 integrated grounding. It's fire code compliant. The Era tool design software, which we have access to, it offers full layout, ballasting plan, material list, and engineering reports. EraCompact has wet stamp support in all 50 states where required. EraCompact reviews all the designs and offers a final engineering report and quote on each system. And also new to AE Express, the light version of this tool is available for installers to use for initial layout planning. So this should speed the process along even more, where you, the installers, could plan out the system, lay it out, and then submit that project to us. We can verify it, help you with the design, and then EraCompact can review that and get quotes very quickly. Rubber EPDM pads are attached to each of the supports. They protect the roof surfaces. There are ballast trays available when required, or higher ballast loading is needed. One single tool, fast installation. So as you can see, there's front feet, middle feet, and back feet for these. The module attached to those feet. There is support for penetrations, which we can, again, we mentioned, that can lower the ballasting or meet seismic requirements. And we also have UL-listed frame mount adapters for microinverters or optimizers. In 2015 alone, 100 megawatts of EraCompact projects were deployed in the United States. AET has been a good partner of ours. Their Ecobee Rayport ballasted racking solution is very popular. It's lightweight galvanized steel. It's a functional, lightweight, cost-effective ballast racking solution. It's available in 5, 10, and 15-degree tilt angles, and optional wind deflectors and anchors can be obtained. Here, the inter-row spacing is adjustable, so we can also fit more modules on a given roof surface in some cases by adjusting the inter-row spacing for your different latitudes. Again, rubber pads protect the roof surfaces. Fast installation is achieved with the top-down module clamps. There is one common bolt for all joints. It is UL 2703 bonding, so very few grounding points are needed in the array. Probably for about 100 modules, we'd have a single grounding point. That would be outputted in the bill of materials and the design guide once they issue a layout. Full design services are offered through AET Engineering, including support, layout and ballast load analysis, bill of materials. Online and on-site installation training is also available. So briefly, I'm going to go through an example here. We're showing that lower tilts and the east-west option could allow more modules to be deployed on a given roof surface, and as a result, greater power output over a year to your customers. So these are using PV watt these are using the SolarEdge design tool calculations for Sacramento, California. Please note that your energy produced will vary by your location due to both irradiance and weather conditions. So this is all in the same building. This is a project that we are currently looking at. So, and the customer wanted to see all the different options, and we did this to help them choose which one was best. So each of this is the same building. It measures 160 feet by 300 feet, and using a 15-degree south racking due to the inter-row shading, we were able to deploy 1,245 modules. These are using 280 REC Twin Peak modules. As a result, we got 348 kW on the roof, and those modules over the course of a year could be expected to put out 569 megawatt hours of power to the customer. By considering a 5-degree south racking, we're still leaving our walkways, we're still leaving adequate spacing around all the vents, so about the same square footage that we're deploying this on, but we were able to fit 1,430 modules on this roof surface, and that is about a 50 kW increase. So yes, each module is producing slightly less power, but overall power output, we increased by 9%. So we got 400 kilowatts on there, resulting in 620 megawatt hours produced in the first year. Furthermore, if we switch to The EraCompact 10-degree east-west racking, again the same module building footprint, 1,586 modules were able to be placed in that area. This resulted in a 444 kW array producing 672 megawatt hours, which is an 18% power increase over the 15 degree south. So also, let's look at the ballasting requirements needed here. So on the 15 degree south tilt racking, again, 1,244 modules. That would easily be serviced with 8 SolarEdge 33 kW inverters and optimizers. And that required 3,270 ballast blocks, and it resulted in a 3.2 pounds per square foot roof dead load. The 5-degree racking, even though there's more modules up there, we needed less ballast blocks. So 1,400 modules only needed 2,389 ballast blocks per the output calculations. This had a lower roof dead load of 2.8 pounds per square foot. So we did have to add an inverter to service a larger array to achieve the 620 megawatt hours that was produced. But if that's what the customer is looking for and trying to get the most power output for a given roof surface, then going to a lower tilt definitely is the way to go. Considering the 10-degree east-west ballast racking solution, we got 1,586 modules of homes for those on the roof. Again, another inverter was needed with another optimizer for this larger array. And we were able to produce 673 megawatt hours. So that's an 18% increase over the 15 degrees. Now here's the nice part here. The dead load dropped to 2.35 pounds per square foot. Even though we have 1,586 modules on this roof, up from 1,244 the 15 degree south, it only needed 910 ballast blocks. In addition, the racking cost per watt could be half of that of the 15 degree racking. The 15 degree needs more materials. It needs the wind screens in the back and the ballast trays as well. That is really not required for the 10 degree east-west because the wind really can't get under that system. So really, very nice system to consider. Let's talk about rapid shutdown requirements coming up for commercial systems. So under NEC 2014, inverters need to have a rapid shutdown system employed. So the DC conductors, the live DC coming from the inverters, any live DC has to be able to be cut within a listed time frame. So if we locate our inverters within 10 feet of the array, we are compliant with NEC 2014. This is the method that most inverter manufacturers, central inverter manufacturers, are using to meet NEC 2014. So three-phase string inverters, they're NEMA 4 rated typically. They're designed to be placed out in the weather, in the elements, next to the array on the roof. So we have some options to put those inverters next to the array. AET offers a ballast racking. SMA has a rack specific to their tri-power inverters, or a custom designed racking system could be used for these inverters. Please note though that putting inverters on the roof, that is taking up some module space. So be aware that you do have to, when you design these systems, if you're using a central inverter, make sure you account for that space that the inverters need to take up. Separate remote disconnects could be used to meet code. We currently only have one solution that we have available, which is the Innovative Solutions Rapid Shutdown Box. That is 1,000 volt DC rated. This is different than their 600 volt rated residential solutions. But if you are doing a higher voltage inverter system, you need to consider that all the systems and the components are rated for 1,000 volts DC. SMA, ABB, Fronius, Jinlong, all inverter manufacturers that we have offered. They do not have a branded RSD solution for 1,000 volts. They only have it for 600 volts. Please note also that SolarEdge, Enphase, and the new HighQ inverter systems, they're inherently rapid shutdown, so we don't have to employ one of these solutions or mount the inverters on the roof to meet NEC 2014 jurisdictions using these three systems. Here's a current map as of March 1st, 2016. of NEC adoption state by state. Currently, there's only 17 states that are on the 2008 code or the 2011 code. 29 states are currently under NEC 2014, and 5 states are applying that code in at least some jurisdictions. More and more states will be adopting this code this year. We'll see this map be primarily pink by the end of the year, and soon California as well will be in NEC 2014. Here is the Innovative Solutions 1000 VDC Rapid Shutdown Box. So this is configurable for up to 4 DC strings in, 4 DC strings out, and both positive and negative circuits are interrupted. They do offer custom larger enclosures, so if you didn't want to employ multiple boxes, or if you have 2 MPPT circuits, custom boxes can be obtained, or just multiple of these boxes could be used. Ground level reset is achieved. We don't have to go up on the roof to reset these. And it is powered by a separate transformer that's installed and powered from the ground. A separate e-stop button for emergency usage if required or if desired can be obtained. So one e-stop button could interrupt the transformer and therefore trigger a rapid shutdown event for all the connected boxes. So new to AEE this year is the HighQ True String Commercial Inverter. This inverter is pretty unique. It's a 24-pound, 10 kW in, 8 kW out, 480 volt, 3-phase inverter. You can see on the picture on the top right, it can be deployed like a optimizer or microinverter. It's a little bit, it's about twice to 3 times the size of an N-phase microinverter, if you're familiar with that. So it is 24 pounds, but it can be attached to the racking under the array. Since it is located within 10 feet of the array, it's actually under the modules. It meets NEC 2014 code. It has 2 DC inputs, as you can see in the middle picture. So strings of 5,000 watts of modules go to each of the 2 MPPTs about. Varying string lengths are allowed since it's 2 separate MPPT trackers. And the connectors speeds and installation time. So your module strings just go right into there. The trunk cable, the AC output cable, the AC whip, you can see the output there, leads to their AC splice box, and 3 of those 8 kW inverters will be combined there, and then the combined output circuit would land on a 40 amp 3-phase 480 volt breaker. It's in a waterproof, robust NEMA 6 enclosure, so it's fully enclosed there. And again, we mentioned that it's mounted onto the array. It is 100% designed and made in the United States, and it's also available in a 5.75 kilowatt power output for smaller, for 208 volt 3-phase Y installations. Here's a view of ballasted racking solutions if we choose to put inverters up on the roof. AET offers us their ballast racking sled, and it can be configured with most inverters. There is options available for shade screens, for AC and DC disconnects to be added, and also for load centers if you have multiple inverters in series. Those are options which we can also ask to be added to a system. Also shown there is the redesign for this year SMA Ready Rack 2.0 system, and that includes the CU1000 combiner disconnect, and is specifically for SMA tri-power inverters. They will custom build these racks. It ships as a unit folded down. It folds in. The inverter is already installed. You need to specify which inverter you're using prior to ordering, and it is ordered as a system, then lifted up on the roof with a crane or racking system, and then dropped onto the roof. Let's briefly talk about larger ground mount arrays. So we're seeing customers of ours employing the Snap and Rack Series 200 ground mount arrays, and we can competitively quote and offer that up to about 100 to 150 kW DC. Since specialized systems and studies are not required, people understand the system pretty well. If they're residential system owners, they could just scale up and use this system for larger commercial arrays. An example I'm giving here is one rack in landscape with 24 rows of 4 high in landscape. We can get a 28 kW DC array using the REC 280 modules, and then size that for use with a Fronius Simo 24, SMA Tri-Power 24, or 3 of the HighQ true string inverters. Typically, your rapid shutdown isn't applicable here for ground mount arrays. It's only for rooftops. I think some jurisdictions are starting to think about enforcing rapid shutdown, but hopefully that won't be the case. So 4 of these racks, so 10 3-foot deep piers on the front and 10 4-foot deep piers on the back that are
Glenn, are you there? Sorry, everyone. Looks like we lost Glenn, but hopefully he can call back in. Be here. I'm just going to remind everyone about the survey that will pop up when you exit the webinar. If you complete that survey, then I'll go ahead and send you a copy of the presentation slides, as well as your NAPSEP certificate if you've attended the entire webinar. So please be sure to do that. Also, I've been uploading our webinar presentation recordings to our YouTube channel. So if you haven't had a chance to really check that out, we post all of our webinars up there and some other really good quality content. So I recommend going onto our YouTube channel and subscribing. That way you'll receive a notification whenever we upload anything, any new video content to that. So I guess we'll just give a couple minutes here and hope that Glenn can log back on, because I know we have some really great questions that have come through. So we'll just hang tight here.
Hello, Hannah.
All right, Glenn, are you back?
Yeah, I think my phone just dropped there, so let me take back the presenter role. I had to jump back to my email briefly to get the code, so I had to hide the screen. I apologize for that.
No problem. You should be able to show your screen.
Okay, so from current slide, is this the one we were on?
There you go.
I think it was. Okay. Audience, I'm sorry. I had my phone on for so long there that apparently it decided just to drop me. So let's get back to the webinar. Not too many more slides to wrap up, so hopefully that delay wasn't too bad. So we talked about Snap and Rack Series 200, the piers we would need. So you know, a guy in a Bobcat could quickly dig these 12-inch diameter 3- and 4-foot deep piers. Please note that is dependent upon your location and wind conditions. So that engineering would be spit out on the Snap and Rack design tool, what your requirements were. This array, so the whole array there, the 112 kW DC, could fit in a 100 by 150 foot space with walkways for access. Cost would be roughly 16 to 18 cents a watt, plus you would have to source the galvanized piping and concrete. So pile-driven systems, on the other hand, might require special engineering studies and specialized equipment rentals, and this could add a lot of cost for smaller projects. Here is a picture of the Snap and Rack Series 200 racking system. So we already talked about a lot of this here. Please note also we do have other formats available. We could do 3-high landscape if that's what is desired, but your cost and your packing density for a particular area would be better suited keeping with the 4-high landscape orientation. We get a very high module to power density for a given area. It is UL 2703 listed, so we need one grounding point per each subarray. We have our online configuration tool through Snap and Rack. I believe there's links from AE Express to the Snap and Rack configurator, or you can go to snapandrack.com to do the online configuration and look at the different bill of materials and engineering reports based upon the input that you give it. We mentioned specialized equipment is not required for installation, so that does lower the overall cost. You locally source Schedule 40 pipe, and again, we mentioned residential installers. We can use a known solution for larger and larger projects. AET GE Series. This is a galvanized solution, pile-driven typically, and it is for medium to large or utility scale projects, and can also accommodate uneven terrain a little bit better than a large ground mount racking like the Snap and Rack Series 200. It's typically designed in a two-high portrait mode, so the left picture is showing the two-high portrait. It looks like the right picture is showing three-high landscape, so there are alternative layouts that you can get. But the two-high portrait is usually used to maximize the number of panels that you can get on each driven post. There's only 7 pre-assembled components to the racking system. We mentioned that they're pile-driven. There is options for screw and cement anchored piers. Full layout and load analysis is available, and design work is available from AET to help plan on any given layout. The galvanized components offer corrosion resistance and long service life, and it's lightweight, so it speeds the installation time. Single grounding points again, so UL 2703, lower installation time. The mid clamps will serve as grounding points for the modules, so we don't need to employ weaves for there. If we have a limited area or we want to maximize a given ground mount, we can also consider using the Array Technologies DuraTrack single-axis horizontal trackers. So this tracker system will increase the output 25 to 35% over a fixed array. That's dependent upon conditions and sun access. We get very high energy densities here, and we can maximize the energy harvest for a given array area. Very high reliability, so one motor is used to control up to 750 kW of PV. Fewer motors are required for a given array. Some places will actually keep a spare motor on hand for a quick swap out if it's needed. Motor banks are located on the sides of the arrays for easy access, and also allowing more modules per given area. All of the centrally located gearboxes on the train going down, as you see in the bottom picture, those are sealed and lubricated for the life of the system. Self-locking hardware, so there's no loose nuts or bolts. There's 0 scheduled maintenance that is required, and one pair of module clamps are used per module down the middle of the modules for installation. Has very low install costs and operating expenses, and it's mainly used to get higher output given a certain array space. Finally, let's talk about where we want to put the inverters on ground mount arrays. For ground mount arrays, we can locate them behind the panels on ground racks, and that would save space and simplify your installation. So you can bring your array wiring directly to your inverters that are mounted on the back of the racking for either the Rayport or the Snap and Rack series. We have to consider AC and DC voltage drop considerations, so you have to do the calculations. For 80 volt inverters, do we lose more power running 480 volt 3-phase, or do we lose more power running the 1000 volt wiring for the DC? So if we locate the inverters close to the point of connection, so moving them away from the array more towards where we're tying into, that will allow us to operate the wiring at 600, 800 VDC, which is typical of the tracking in the inverters. Please note that typically the 277 voltage line to neutral power loss is about 2 to 3 times the voltage drop in system losses versus running the DC. However, mounting the inverters under the array might avoid the use of extra DC disconnects. If your jurisdiction is requiring, if there is access to the site, they may require that if you move the inverters away from the array and centrally locate them, that we have individual DC disconnects mounted at the array prior to going to the inverters. 1,000-volt disconnects are not inexpensive. Monitoring is also easier if we can centralize the inverters in a bank. So that is also a concern. So many inverters are daisy chain wired 1 to 2, 2 to 3, 3 to 4. So if you have to, if you're mounting inverters scattered throughout the array, you'd have to consider a plan to link all those. And if we can centrally bank those, then monitoring these inverters becomes a lot easier. That wraps up my presentation here. I do have some pictures of some ballasted rackings after this, but I wanted to leave time for any questions. It looks like it's 9:48 now, so Hannah, is there any questions in the audience?
Great, thanks, Glenn. Yeah, we had a lot of good questions, so let's just dig right in. We had some questions about, at the beginning when you were talking about the MACRS depreciation and the ITC.
Mm-hmm.
Do you know if that applies to an LLC or an S-Corp?
That you'd have to consult the tax advisor. I would assume yes, but remember that you have to pay taxes to apply a tax credit. So one of the problems is we have an industry that is just getting started and they're basically pouring all the money back into the business. Just remember that you have to pay taxes to claim a tax credit.
All right, great. The next question we have, I've heard concrete blocks can add grit and warranty on the roof can be jeopardized. Is that true?
All of the concrete blocks that are placed on the roof are not touching the roof. They are either in ballast trays or there are rubber pads protecting the roof surface. So depending upon the system, but there is no concrete blocks that are directly placed on the roof.
All right. The next question we have, with EraCompact and any other racking that grips modules at the corners of the frames or on the short sides of the module, how does AEE view the significant decrease in module mechanical loading capacity and the consequence that this lowered capacity may have on module micro cracking, due to stress over the 25-year life of an installation?
Good question there. Let's look at the picture here. Yes, we are gripping on the short sides there. I have not heard of that issue coming up. I don't think there have been any long-term studies regarding that. You would want to be careful about specifying your correct snow loading that you would encounter on the modules. I think that is more if the modules are experiencing high stress from snow loading. That's probably where that comes from, and the Alpine bracketing is available for higher snow loads.
All right, and we had a question on the EraCompact design example you used. Mm-hmm. Question what the design wind speed was.
Sacramento, California, I believe. I had that at, I'd have to look at the tool. But that would not affect, so you're talking about, they're talking about this example here, I believe. And I guess they're questioning the number of ballast blocks that are required. So the wind speed was for Sacramento, California, which is very moderate wind speeds.
Great. All right. Our next question regarding rapid shutdown devices. Have you seen or heard of the devices interfering with an inverter's ability to run their arc fault self-checks during initial startup?
I have not heard that. So if you are installing the rapid shutdown devices, the only device we talked about was the Innovative Solutions box, and provided that the proper torque and installation requirements are applied to that box, it should not interfere with the arc fault detection that I'm aware of. If there's sloppy installation in the box and those connections are not torqued to proper specifications, then that potentially could lead to nuisance tripping, I would suppose. Typical with some inverters previously that they were great in the laboratory, but once they got them out to field and people weren't torquing values down to the right levels. I did see, so for the Innovative Solutions box, if I can go back real quick, these are spring-loaded terminals. So not a great picture there, but those are spring-loaded terminals. So provided the wires are stripped and installed per the manufacturer's instructions, it likely would not interfere with arc fault.
All right, great.
Sorry.
All right, Glenn, our next question we have, does mounting string inverters on the roof decrease energy production or inverter lifetime?
As far as inverter lifetime, the manufacturers have, I mean, there's a warranty on each inverter. Outside the warranty period, I don't think the inverter manufacturers are specifying that particularly. So an inverter located in a benign environment probably will last longer. The shade screens are available with the AET racking for putting them up on the roof. Efficiency would drop because the inverters are heating up. I mean, we've grown up and learned not to put residential inverters on the south face of the roof to avoid the heat and heat gain. But if you're trying to meet rapid shutdown requirements and you want to use a central inverter, that's kind of your only option. Or you have to employ a pretty expensive, the Innovative Solutions 1,000-volt system to meet rapid shutdown if you want to locate the inverters in a different area.
All right. The next question we have, are you seeing microinverters being used for smaller ground mount systems?
Not typically, and the reason is your 120-volt line to neutral voltage drop is very, very significant. So if you consider trying to put a, if anybody's ever tried to put an 80-amp sub panel out in the barn and running really big either aluminum or copper wires out to that barn to service that 80-amp sub panel, typically, you know, you got the same thing coming back. So to avoid large line losses, when you do the calculations, it generally pays to use a DC inverter there, run the high voltage DC back to the point of connection, mount the inverter next to the point of connection, run your DC if your jurisdiction allows that under the ground. You're going to see a lot less wires needed there.
Thanks, Glenn. The next question we have, the SolarEdge site analysis tool will often recommend only 2 single-phase inverters on a 3-phase system. What do you think?
Repeat the question, please.
The SolarEdge site analysis tool will often recommend only 2 single-phase inverters on a 3-phase system. Do you think that's correct?
Haven't seen that. No, I personally haven't seen that. Maybe if they're designing really tiny systems, so if you're designing a 6 kW 208 volt 3-phase system, the smallest SolarEdge inverter is a 9 kW 3-phase inverter. If you're designing very small systems, it might default to SolarEdge 3000s perhaps if you got a 6 kW array. But you can easily uncheck those single-phase inverters and rerun the calculation for larger for the use of a single SolarEdge 9 if you are trying to hit 208 volt 3-phase.
Okay.
Did that answer the question?
If it doesn't answer the question, Cassie, please feel free to comment. All right, but we'll move on to our next one for the time being. Glenn, do you know of any restrictions regarding 2 businesses owned by the same person with both going solar and receiving the ITC for both?
I think you need to consult a tax advisor for that. So one owner is owning 2 businesses?
Correct.
So it's basically one guy owning, let's just say, a car dealership and a gas station. So the question is, can he put, well, it depends on how he organizes his business. If he is a sole proprietor and he is paying the taxes and he owns both the properties, for example, let's take a person who lives in one house and owns a rental. He can take the ITC 30% tax credit on both properties.
Great.
If those businesses are incorporated separately, then the business is filing the taxes, and you probably have to keep the tax credits with each business. But again, I'm not a tax attorney, so please consult your tax attorneys for these questions. We do know that considering the tax credits, considering the macros depreciation, people who understand this can intelligently present this to potential customers and show them the net system costs and help them navigate in their particular tax region, are selling more systems. So they can show these benefits up front. The customer is not left in the dark about these credits. They're not leaving money on the table. They can install larger systems, provide more options to the customer, offset more of the power that they need, and overall get more references for future businesses because they've really served that customer very well.
All right, thanks, Glenn. The next question we have, can you recommend an online tool for demand offsetting calculations?
Nope.
All right, and the final question we'll go with here today. Do you think single axis trackers live up to the promise of 25 to 35% increased production for most systems?
Depends on if you have an open array field in a desert or in Kansas. If you basically have high mountains to your east and west, or you have shading due to hills and valleys or trees, tall trees to the east and west, then you're not going to do that. So proper analysis using a site design tool. If you still have access to your solometric sun eyes or another site analysis tool that can determine when the sun will be hitting those modules at what hours and calculate that over the course of the year. It is site specific. So yes, we've seen that, but it is site specific. So poor information results in poor system design.
All right, thanks, Glenn. That concludes our Q&A portion of the webinar.
Yep. I'm just going to quickly just go through the pictures here. So here's a view of your EraCompact 5-degree south racking. These will be included in the slideshows, so when Hannah sends these out, you can take a better look at these. We have about 3 minutes left, so I'm just going to go through these pictures. Here's, you can see the module rows increasing a little bit more for the 10-degree south. Here is the east-west option. As you can see, we're eliminating most of the spaces between the modules. There's a walkway left to access that vent, but you can see the power density here is greatly increased. Here is a view of the Brayport Ecobee racking, showing some of the components there. You can see the ballasting there that is on the special pads. None of those ballast blocks are touching the roof surface, and that is typical with all ballasted systems. Here you can see the ballast blocks again in a special tray. There's nothing touching the roof there as far as the ballasting goes, and the actual physical contact with the roof, there's rubber pads protecting there. Here is a Brayport system being laid out and installed, and then finally here's the completed system. So just wanted to go through those briefly. And again, these slides are available, so if you want to take a better look at these pictures, they will be included in the slide deck. This concludes my portion of it. Hannah, if you want to close us out.
All right, thanks, Glenn. Thanks, everyone, for joining us for our presentation today, Commercial Systems 101. And just a reminder that to get those slides that Glenn mentioned, you have to complete the survey that pops up once you leave the webinar. So it'll be in a new window, or it'll be emailed automatically within an hour. So keep an eye out for that. Also, join us next month, July 22nd, for the next webinar in our monthly webinar series. The topic is rapid shutdown. So very important for certain states, but always good to know. So you can register for that webinar anytime. We have them listed on our website, aeesolar.com. You can register for whatever webinars you would like to see. All right, and just a reminder that I will be posting the recording of this webinar on our YouTube channel. So if you haven't had the chance to check out our YouTube channel, it's just called AEE Solar. You can type that in and search in YouTube. We have all of our past presentations. So, all right, thanks again, everyone, for joining, and have a wonderful weekend.